states that if you have something raised to, so this is power, raised to the power rule, right? The power, so this is the power rule. The power rule. Anything raised to the power. So if you have a function like function fx is equal to x to the 5 is equal to the derivative is written like this, x is equal to the derivative of x n minus 1 n in front. So that means you have derivative is equal to x to the 5th is the derivative is n to the x where n minus 1, meaning that if you have a function x to the 5th, fx is equal to x to the 5th on a graph, that means you find a slope like this. What is the derivative? What is this? What is the function that will give us the slope of the line at any point on the graph? So what you do is you simply take n, take 5, you put 5 in front, and you minus 5 minus 1, just like any function. So the answer would be 5x to the 4th, and that would be the derivative function. This function would give you, when you plug this is the derivative, so this function allows you to find any point on the graph of x values, any point on the slope of any point on the graph. That's it. So if you have this function g of x is equal to 4 to the power of x, this function can be written in the power form. So to write this in the power form, you could rewrite this as g of x is equal to, this is the same as saying x 1 over 4, because when you put this in form, the 4 comes outside, the 1 comes here, this comes 1. So this can be written as this. So now it's in the form where you have x and a power, and the same concept applies. So you have g of x, so the principle is you take n of x and you put n minus 1 to it. So you take you put 1/4 in front, x, and you take 1/4 and you minus 1 from it. So this becomes 1/4 x, 1/4 minus 1. Well, if you have 1 on the top, if you put 1 on the bottom, you have to multiply top by 1. So 1 by 1 is 1. So you get, no wait, this is what you do. If you have 1 on top, right, you can multiply top by 4. So if you multiply top by 4, you gotta multiply the bottom by 4. So you get 1 over 4 minus 1 over 4. When you have the same denominator, just minus the top. So 1 minus 1 is 0.4. Right, so this becomes 4 by 4 becomes 4 over 4 minus 1 over 4. So 1 minus 4 is minus 3 over 4. So the answer becomes 1/4 x minus 3 over 4. And this is the derivative of the function. So let's say I have a function of g of x is equal to 1 over x. This can be written in the power form by rewriting this statement. Well, what is 1 over x? 1 over x is the same as writing x minus 1. So now you have 1x to the power of minus 1. Now you apply the principle of derivative. You apply the principle of the derivative, which is written like this: h derivative of x is equal to nx n minus 1. Right, so this is equal to, well, this is minus 1, so you put minus 1 from x, and this becomes whatever was there, 1 minus 1, because there's 1 there. No, this is not 1 minus 1. What was the number on top? Not negative 1? So this would be negative 1. Right? So this was negative on top. So this n becomes this negative 1 comes here. Right? So the question is negative 1. This was negative 1. So you take negative 1. This was here. This n is a negative number. So this is supposed to be negative. So you get a negative number here. So it's negative 1. Negative n minus negative 1. So 1 minus 1. So you get negative 1x. Negative 1 minus negative 1 is negative 2. So since we started with a 1 over x, then we could write this as, we could leave it as this, or since we want to write it in this form, what is x to the 1 power? Wouldn't it be, well, you could leave the 1 on top, you put the x at the bottom, this becomes positive. That's from algebra, from math 143 or 119. This is same as this, so that becomes, so the derivative of this function is negative 1 over x squared. So for this function on the graph, this is the function on the graph like this, xh is equal to 1 over x. The derivative is equal to this function. So we can plug this function and find any point on the graph. Find the slope of any point on the graph using this function. So we're going to so the first one we're going to is the multiple rule. Multiple rule is like if you have a function y is equal to 4x to the third. So before we were dealing with x to the power. Now we have a function where you have a number in front of it multiplied by the x. So how do you solve this? So if you want to find the differential of that, you write that in differential form. So differential is y prime is equal to differential of respect to x and this function here, 4x to the third power. So we do the same thing. We say x to the power is, you bring down the n minus 1 and bring down the n here. So in this case, all we have to do is, for this function, you can take the 4 out. If the differential of a constant can be taken out, so you get 4 differential x, and then you solve for x to the third power. So you get 4 out, differential over, so we bring the 3 down, and minus 3 from 1, so you get x 3 minus 1, and then you get 4 over dx is equal to 3 minus 1 is 2, so you get 3x to the second. This is 4 to be here. So the 4, now you could plug the 4 back in, so you get y differential is equal to 4 by 3 x squared. So you get 4 choose that 12x squared. So that's the differential of this function, 12x squared. So all you're doing is, for a constant number, you take the number out and then you just solve for the function like this and just plug the 4 back in. So you get 4 by 3x and reduce this by 1, so you get 2. 4 choose a 12x squared. Example 2. Example 2. You have the function 4 square root of x. You want to find the differential of that, of fx. So you find fx is equal to the differential with respect to x of 4 square root of x. So you can take the 4 out to get 4. Now you want to find this. This is not in standard form, so to write this in standard form isn't the square root of x squared 1 day is the same as saying x 1 over 2. So now it's in standard form. Now you have the x component. So you get 4 dx. The rule is to take n x, you take n, put the front and you take n minus 1. So you take the half in front, so you get a half x, and then you get a half minus 1, which is, you could say, multiply 1 by 2. So if you do whatever you do at the top, you do at the bottom. So you get half minus 2 over 2, which is equal to 1 minus 2 is minus 1 over 2. So half minus 2 is a half. 1 minus 2 is minus 1 over 2. So you get minus a half. So you get this equal to 4, right, differential of 4 dx by half x minus a half. I can just plug the 4 back in, so you get the differential of 4 by a half x minus a half. So when you this will cancel, so you get 2x minus a half. So if you want to write this now in positive form, this is 2x to the negative a half. This can be written as 2. You put the power at the bottom. Anytime you put the power at the bottom, this becomes positive. So this is the same as that. That's the answer. So let's say we have this function here. F of x is equal to 3 over 4, 3 by x power of 2, right? We have to write this in standard form, which is n to the x is n minus 1. So we have x to a power. So we can actually rewrite this function. We want to rewrite this function because this is 4 multiplied by this. This is same as saying 4 multiplied by this 3 on top. So this function can be written as 3 over 4 multiplied by 1 over square root of x squared to it, isn't it? If you multiply this out, you get back the same function. So you separate the x value, trying to get the x by itself. So now you can take out the radical. This is 3 radical square root of 2. You can take out the radical by rewritten this as x over 2/3. This becomes the bottom, this goes on top, so 2/3. This is the same thing as this. So you get x radical 2/3. Right, so now we want to try to make this into this form, so we have to get the x on top. But when you put the x on top, this becomes negative 2/3. So now we have in this form. So you leave this as 3/4 and you solve for this. So this becomes negative